Welcome to this Intro to Capital Modelling presentation on the difference between per risk and per event excess of loss reinsurance. We're going to start with a quick recap of terms and then move into a practical demonstration in Python. So imagine you are an insurer and you have a portfolio of insured assets. You want to protect these assets against extreme losses, outsized losses, abnormal events. You could use facultative cover, which protects individual risks or assets, such as this particular building. But it may not be efficient to organize cover for your entire portfolio in this way. So it's very common to arrange treaty cover. Treaty reinsurance protects all the assets in your portfolio, but this could still be arranged on a per risk basis, where the cover would respond to losses on individual assets, or it could be on a per event basis, where the cover would respond to the aggregate loss across a number of assets from a common event. When you're modeling reinsurance, it's important to understand whether the cover you're modeling is per risk or per event, and understand what defines an event, which will typically be described in the per event wording. So here we have an individual risk loss. This would be able to recover against FAC on that particular asset, or against the per risk treaty cover if the loss is large enough to get into the cover. But it wouldn't be able to recover on your per event treaty because it's not a qualifying event. Here we do have a qualifying event. So here we would add up the loss across all of the assets that are affected, and that total loss would be the subject losses presented to the reinsurance, and we would generate a recovery from that. But what if some of our assets were also individually protected by facultative reinsurance, or if they could individually recover against the per risk treaty that we have in place because they have suffered a very large loss individually as a result of the event? We're going to be having a look at how you organize the calculation of the recoveries between these two different types of cover. Typically, facultative cover will act first, and then per risk, and finally per event. But it's important when you're modeling that you understand the inuring relationships between the different covers involved. Let's move across into a Jupyter notebook and have a look at how this modeling might happen in Python. So here we're going to set up two levels of frequency. We're going to have a frequency for major events. So this will be the flood in the example from the slides. So here we have three simulations in our model. In the first simulation, there are 3 events. In the second simulation, there are no events. And in the third simulation, there are 2 events. And this is going to be our major event frequency. Then for each of these major events, so for each of these, say, floods, we're going to have a number of individual risk assets that are affected. So here I've got, from simulation 0, 3 events. In the first of those events, we've got 1 affected asset. In the second of those events, we've got 3 affected assets. And in the third of those events, we've got 1 affected assets. Then in the second simulation, there's no major events. And final simulation, I've got 2 major events. In the first of those, there are 5 affected assets. And in the second of those, there's 2 affected assets. We can create this kind of structure where now I've got the loss count per event are those figures, and those are acting over this underlying major event frequency structure. And the final thing we want to set up is the actual loss amounts. So if we look at our losses here, I've got 1 plus 3 plus 1 plus 5 plus 2. So I've got 12 individually affected assets across the whole set of simulations and all the events modeled. And so these are those 12 losses that we've just got for the example. So we can see here we've got these individual risk losses of these amounts, and this is the underlying frequency structure that they correspond to. And we want to start modeling some per risk and per event reinsurance. Now for the per risk, we've got some figures here, some deductible limit, number of reinstatements, and a percentage placed. And if we want to think about how to go through calculating these, well, the first step would just be to apply the limit and the deductible to each of the individual risk losses. And we can just do this simply by applying them with the usual min-max formula. Let's take a look at this. We can see that our very large loss here has made a full limit recovery of 100. We now need to make sure that we are taking account of the number of reinstatements that are available. So when we've got multiple individual risks making recoveries against the per risk cover, each of those is eroding part of the available limit. And in this case, we only have one exhaustion of that limit available because there are no reinstatements. So we need to work out what the total erosion of that limit is and see if we've gone over the possible total limit that we have available. So we're going to aggregate up into simulations now. We're going to aggregate across the individual events. And this gives me, for each of the 3 simulations, the total recovery that I've made on all the individual risk events, in the individual risk losses that have happened across all the various events. We're going to compare these to the total available limit. The max recovery we can make is the limit times 1 plus the number of reinstatements, but we only had 1 reinstatement available. So our constrained recovery is just going to be calculated as that total recovery, and the smaller of the maximum available recovery and the total recovery that we would naturally get. So here you can see in the first simulation, we weren't constrained because we were only naturally recovering 50, which is okay inside our single limit of 100. But in the third simulation, we would have naturally wanted to recover 170 across the various risk losses that have happened, but we're constrained to just recovering 1 exhaustion of the limit. So now we would want to scale down those individual recoveries, the original recoveries we made, the unconstrained recoveries. We want to scale those down to take allowance for this sideways exhaustion in the cover. So here I can look at this ratio between the constrained recovery and what the total recovery would have been without the reinstatements. So here, just a scale factor of 1 for the first simulation because there was no exhaustion. But here we've got a near 60% scaling. And now we can apply that scale factor to all of the recoveries so that they will, in aggregate, not exceed the total available limit. So now we can see that our first recovery hasn't been affected. These other recoveries have been scaled down. This one on its own would have naturally been 100 before, and that's been scaled down to this near 60 because of that scale factor we've calculated, and the same for the other losses. So that in aggregate, these should add up to the 100 available limit. And the final step would just be to calculate the placed recovery by allowing for the percentage placement of the contract and multiply that by these constrained recoveries. So we get a final answer here. 25 in the first, and this 29.41 here in this very large claim that we had in the middle. And we couldn't make this a bit easier by collapsing it into a function. So we're going to create a function here to calculate risk XoL recoveries. We're just going to pass in the deductible, the limit, the number of reinstatements, and the placement as parameters. And then we're just going to follow these steps and return the final placed recoveries. And we can see that's going to give us the same answer. So now I could generate more easily the risk XoL recoveries simply by running this function and passing in our losses and passing in those parameters that we had before. I can generate this in one go, and we see I get the same XoL recoveries, 25 for the first and this 29.41 in the middle. So that's our risk XoL recoveries. And typically the risk XoL will apply before the per event cover. And so we'll want to net off the risk XoL recoveries from our losses to get losses net of risk XoL. If we have a look at this, we'll see we've got this reduction, 100 goes down to 75. Here our 150 has gone down to nearly 120. And now these losses are net of the risk XoL, and they are what are going to go forward to recover against the per event XoL. So what's different about calculating per event XoL? Well, the mechanics of the excess of loss are very similar, except that it's the aggregate losses by event that we want to pass in. So instead of passing in the individual risk losses, we want to add up all the losses across all the risks within each event. So we're first going to calculate the aggregate event, but applied to the risk losses net of that risk XoL. So here we have the net losses, but summed up into the 5 major events that we have. See here we have 3 events in the first sim, no events in the second sim, 2 events in the third sim. So these are those 5 events now with total losses across all the risk, the individual assets, and net of that risk XoL. So these are what we want to take forward and pass into the event XoL reinsurance. So we want a function to calculate event XoL recoveries. And initially, we're just going to start by borrowing and reusing the function we had to calculate the risk XoL recoveries. We're just going to use the same function here. We're going to set up different terms. And now our event XoL recoveries, we're just going to apply this function, calculate event XoL recoveries to our losses. But now our losses are the event losses, so summed into the event level and net of the risk XoL. But really, this is just to make the point that the actual mechanics of the function, the mechanics of the layer, are very similar. It's just the nature of the losses going in that's different. We can run this. We now get the recoveries based on those layer terms applied to those aggregate event amounts. Now that first one did not exceed the 100 excess deductible that we have for our event cover. But these 2 events did, and they share this total limit of 100 that's available on a per event basis. We can then calculate the net losses net of the event XoL by subtracting the recoveries from the original losses that we had. Gives us our net losses here. And then we can aggregate up into total losses by again aggregating over the events as well, and just ending up with a final net amount in each of the 3 simulations. And as a quick sense check, we can just compare this to what we would get if we took the losses that we set up originally and aggregated those into the simulation. And then in the final simulation, it's the risk limit would have applied in full times its placement, and also the event limit would have applied in full times its placement. In the first one, I think we got half a risk limit applied, and then times the placement took that down to 25. So these are the sort of recoveries we're expecting in total. And we can see those are the values that we're getting here. So that was deliberately quite a simple example with only a single class of business. We started looking at that really just to focus on the difference between the granularities of the loss amounts. So the individual asset or risk-based losses being passed into the risk XoL contract, and then that step of aggregation into the event totals to then pass them into the event excess contract. But we didn't have any classes, and event excess and per risk excess also behave a little bit differently when you've got multiple classes involved, so it's worth extending the example to look at that. So we start with the same idea of having a major event frequency, but now we've got 3 different cohorts of losses. So we've got 2 different classes of business with 1 year of account affected in the first class and 2 years of account affected in the second class. But importantly, it's the same major event frequency structure that underpins all 3. These events represent real-world events that trigger losses on multiple policies, on multiple assets that could be covered by different classes, different or captured in different classes of business, or covered by different years of account. So different classes, different years will be affected by the same events, and it's important that they are the same events if you're going to aggregate and get event totals, and you need to make sure that you've got them aligned so that when you do the aggregation, it is going to be like-for-like events that are being summed. So this is very much demonstrated here by us having this same major event frequency structure underpinning all 3 classes. However, the number of individual risk losses that are triggered when each event occurs could be different for the different classes and the different years. So in this first class, this loss count per event profile follows the example we saw previously, but the second class also has affected, covers different assets. Different numbers of assets are affected by these events differently. So in this third event that's being modelled, class 2 isn't affected at all, for example. And finally, we have to extend the actual loss severity amounts that we're modelling. So in this example, we've kept the previous example's loss profile for the first class, and we've just put in some additional losses for the 6 risk loss amounts that are generated for this 2023 underwriting year for class 2, and there's 5 risk loss amounts that are generated for 2024. Now we still want to go through the same process, and much of the code below is going to be very similar to what we saw before. So we still want to apply a risk XoL cover with these terms, and this first step of calculating the individual recoveries before you think about reinstatements follows exactly the same step. It's the min-max formula with the limit and the deductible, and that's just being applied to each and every risk loss, regardless of which class or year, as long as it's covered. And we get our profile of recoveries here. But these recoveries don't take allowance for the fact that there's zero reinstatements. So you can only recover up to 100. And here we've got a number of risk events all recovering against this policy. And this one on its own exhausts the full limit. So as before, we're going to have some kind of sideways erosion, sideways exhaustion here, and we're going to need to pare down these recoveries. So that's the first step we get to, where we're going to have to do things slightly differently. So here we have the calculation as we did it before, where we were calculating the total recoveries, the total of the recoveries before reinstatements, just by aggregating those up into SIM. It's no longer good enough just to aggregate it into SIM. We're also going to need to aggregate it across the different classes and years to work out for each SIM what the total work out what the total recovery is. So we can now have a look at that. This gives us our total recovery. We can then follow the rest of the example quite closely. The available max recovery is the same. It's the same application of just applying this as a upper bound on the recoveries to get a constrained total recovery, which in this case is biting in both the first and the third simulation. Then calculating this sideways erosion scale factor in exactly the same way as before, and using that to scale down the recoveries. And then finally applying the placement. So those bits are all exactly the same as before. And so our modified function to calculate risk XoL recoveries really looks exactly as we had it in the previous example, except that we have put in this sum step here, so that when we're calculating that sideways exhaustion of the reinstatements, we're thinking about all the contributions to that across all classes and years. That means we can now calculate our recoveries just as before. So we'll we now get our variable risk XL recoveries just as they were before. We can just do a quick check to make sure this is in fact giving us the same as before. So we could go up here and we could apply this to the losses, but we could just filter on the first class. And we can see we get these recoveries as we have before. You may remember some of these numbers. We had the 25 in the first, and we had this 29.41 in the middle here. So we can see this is giving us similar results as before. But it can also be run across all the classes now. The following steps are really exactly the same as before. We can net down our losses for the risk XL recoveries just by subtracting. We can then think about moving on to the event excess. Now, this is again a time where we have to think about what it means to have multiple classes. So as before, we're going to need to aggregate into the event, so we can do away with the individual risk loss granularity at this point and aggregate into the events. So that's definitely a good step. This gives us our up to five major events here. 3 in the first sim and 2 in the third sim, with nothing happening in the second sim. But when we want to present our event losses, to the event excess of loss cover, we want to be presenting the total loss across all classes and years, because we're allowed to aggregate up all the losses incurred on all the affected assets by that event across all the covered classes and years. So this is where we want to bring in the sum. So we're now bringing in a sum here on the gross losses, on the subject losses, before we present it to the layer term. So this now gives us our total loss. So the class and the year dimension have been collapsed, and we're just looking at that total loss per event now. Now, because we're passing in the subject losses at a total event level, the layer will apply to those and will give us recoveries at a total event level. But it's often useful to have the recoveries allocated back out to the individual classes and years again, both for reporting purposes and because it may be important for downstream further inuring reinsurance calculations. So we're going to need some kind of allocation mechanism, and a good one is to look at the total gross loss for the event and the ratio of each class year's contribution to that. So here we're looking at the numerator has got the classes and years still intact. The denominator is the aggregate across all of those. And that's a good kind of ratio to use to allocate. So if we look at these allocation proportions, something like that is what we could use to allocate out the recoveries back to class and year. And just to check that that is kind of being calculated properly, we can do a little control check here. So if we take the total losses and apply this allocation to them, it should give us back the individual class year losses. And so this check should be very close to 0. And it is. So it looks like a sensible way of calculating the allocation proportions. And so we want to build this into our modified event XoL function. So we're no longer using exactly the same function for the event XoL recoveries as we did for the risk XoL recoveries, because we need to deviate in the way we handle these gross losses. So the subject losses now, this is where the sum is happening. So we're now summing early before we present the losses to the contract. They're getting aggregated across class and year to give us the total event losses. This means we don't need to do the sum here as we had it with the risk XoL, because everything is already at an aggregate level. There's no need to do the sum at this point. But the rest of this calculation is very much the same. But now we do this calculation of the recovery allocation, as we discussed just, and then we apply that to the aggregate recovery by event. That's going to give us recoveries allocated out to class and year, and finally we can apply the placement. So let's have a look at what that looks like if we use these layer terms and apply it to our recoveries. Here we get our event XoL recoveries. You can see they are allocated out to individual class and year. And then in exactly the same way as before, we can calculate the net losses by taking the gross, which are already net of the risk XoL, and taking off the event XoL recoveries. And then we can aggregate up into sim and aggregate across the classes, and we get our final results. So thank you very much for watching. Please leave any comments and get in touch if you'd like to discuss further.